How's it going, everybody? In this video, we're going to continue on the setting up the service VPN for basic operations, where in this video, we're going to focus on static routes. So that's going to be a static route configured on the vEdge to point to loopbacks or connected LAN segments that are attached to devices behind the vEdge. So for example, if VPN1 here, I should say over here, VPN1 here needs to reach something on switch 16 or router 5 or something along those routes that are more than one hop away, and it's not this connected link between switch 16 and VPN1, then you need a static route in order to reach that. So we're going to configure the static routes underneath the service VPN. So that's a service VPN specific configuration. And so in other words, we'll go to the VPN template, the feature template, and we'll add the static route, and then we'll push that config down to the appropriate, and we're gonna the appropriate vEdges, and it'll have to be device specific, so that we can go in and adjust those devices accordingly, because you wouldn't want to have the same subnet at multiple locations. So in that case, this is basically what you'll end up needing to do. So static routes will be configured on the vEdges to point to subnets that are behind or more than one hop away from the vEdge. So there are other options like OSPF or BGP in this case, but we'll take a look at those in later videos. So right now we're just doing the extreme basics right now with the routing. So let's go ahead and take a look at this from the CLI perspective. So the CLI is pretty much always going to be the easier way of doing this. So let's go ahead and type in admin and then admin again, and go to global config, and underneath VPN1 on switch 16, there's a number of, I've got to bring this all the way over. So let's go ahead and take a look at the show IP interface brief. And I have a connection to a couple different subnets that I want to be able to reach. I have a loopback address here of 10.1.16. I also have, you can disregard VLAN 109. So I'll type in no VLAN 109 and no interface VLAN 109. Okay, we'll take a look at the connected link between switch 16 and router 5, so this 10.5.16. So what we're going to actually do for VPN1, we're going to create two static routes, one for the prefix to get to 10.1.16, or sorry, the 10.1.0.16, so loopback of router switch 16, and then this connected link between router 5 and switch 16. We'll do that real quick, get that guy squared away. Now, in the VManage piece of this, if you want to create multiple static routes, you can. You just have to make sure that they are different in some way. So for example, you need to make sure if you're going to say create two default routes, that you're not creating the same default route globally, right? So if you go to the global option, that you don't say global default route, global default route. So if you do that, then you're going to have a duplicate entry, and then the vEdge will reject it. You need to have some sort of uniqueness per static route in order for it to work. And we'll take a look at exactly how that comes into play, because we have some subnets on each one of the vEdges, or on the routers sitting behind the vEdges. So for example, 14.14.14.14/32, and then some loopback address that's simulating a connected LAN segment. So we're going to create static routes for both, just so you can see how that comes into play. So let me go ahead and get out of the way and get this configured. We're going to type an IP route to 10.1.0.16/32 with the next hop of 10.1.16.16 and hit the enter key. I'm also going to type an IP route to 10.5.16.0/24 via 10.1.16.16. So a quick show config of that breakdown. That's the configuration that I'm going to throw at the router. I'm going to go ahead and commit that. Now on router 5 here, we go ahead and do a show IP interface brief real quick. That interface is connected, and if I'm going to go ahead and throw gig01 into a VRF. So we've talked briefly about VRFs already for the service VPN, and how VPN0 is different than VPN512, and how the transport VPN is different than the service VPN. They're two separate VPNs or two different VRFs. So I'm going to show you how to create a VRF on a router. It's really simple, and this will be what they refer to as VRF lite. where you create a VRF that does not have anything to do at all with MPLS. If it's an MPLS VRF, in other words, a VRF created on a provider edge router in an MPLS VPN service, then that is not VRF Lite, because then you're using VRFs to separate customer A from customer B, and then you're using MPLS to get from the ingress PE router to the egress PE router through the through the MPLS backbone. So let's take a look at exactly how to do that. I'm going to come up here and type in VRF definition, and I'm going to just type in, I'll say SD-WAN, and then the address family will be IPv4 unicast, and then the route distinguisher value will be 5:5, something very simple. I've already got it configured, so do show run section VRF. I don't remember typing that command in on this box. Oh, it's already set. Okay, cool. So let's go ahead and do show run interface gig 0/1. Right now, oh, he's already in a VRF. Okay, perfect. I forgot that I had done that already. So when you create the VRF SD-WAN, you then place the IP address on the interface, and then you're squared away. So if I do show IP route VRF SD-WAN, I don't have a static route, but I am learning OSPF routes from this guy. So if we were to do a show IP route, do show IP route, so he's got, that's a little bit weird. Why does he have OSPF routes? Do show IP route, do show run section VRF. I don't remember creating a VRF on. Oh, you know why? I know why. There's no VRF configured, but do show IP OSPF interface brief. I do have it running on that interface. So do show IP OSPF neighbors. I do have an active connection with router 5, so we're good to go there. So what I'm going to go do is I'm going to go back to VEdge 5 or router 5. Where is router 5? Router 5 is right there. And I'm going to type in IP route VRF SD-WAN 0.0.0.0 0.0.0.0 10.5.16.16, and then do show IP route VRF SD-WAN. Now I have a default route back to it. So when it comes time to test connectivity from router 5 or from the switch, I'll be able to send the traffic out to VRF. So there, we're good to go there. So now if I go back to VEdge 1 and I've committed the config, do show IP route VPN1, we can see that these routes are, we have a static route to 10.5.16 right here, and we also have 10.1.0.16 right there. Now if I look at the bsmart, show OMP peers, I should be receiving more prefixes in from VEdge 1. I'm receiving 6 in now. If I go to VEdge 3 and show IP route VPN1, I should be receiving 10.1 here, and I'm also 10.5.16 there. Okay, so the CLI piece is done, right? Pretty straightforward, not very complicated, right? Simple static routes. What I'm going to do now is we're going to jump into the VManage and get him squared away and get all that dialed in. So that won't be very difficult. So let's go ahead and start that process up now. So the way to do that is on the VManage, go ahead and log in real quick. And underneath here, we're going to have to go to the feature template for each VPN and add a static route. It's sometimes it does this to me, and I don't know why it does that. It's weird that way. Okay, so what we're going to have to do is configuration and then templates. And then on the feature templates, for each one of those devices, so we're going to say dual site first. We'll just get that one out of the way since we're right here. So for VPN1, so the VPN1 template, not the interface, but the template itself for the VPN. Go ahead and edit this. And underneath the IPv4 route, this is what we're going to set. So we're going to say on VEdge2, right? What we're going to do is we're going to create 2 static routes. We're going to create a static route, and we're going to say prefix, in this case here, will be, we could say device specific if we want to, but we don't need to really. We're going to type in, actually, you know what? In this case here, I will go device specific because you might have other VEdge, other locations that have dual VEdges. So we're going to say device specific. The IPv4 VPN1 IPv4 prefix, like so. And then I'm going to set the next hop here, I'm going to say device specific as well. So we'll type in VPN1 and the next hop IP, like so. Okay, and then add. Okay, so that's been added. So I'm going to go, you can make this optional as well if you want to, which means that you don't have to populate the field if you don't want to. I'm going to go ahead and add. I'm also going to create a new IPv4 route. I'm going to create 2 of them. So could you get more specific? You could, but in this case here, I'm not going to. I'm going to say device specific for VPN1. For some reason, moving the hover away removes it. I don't know why it does that. There we go, VPN1 IPv4 prefix. And then the next hop will be, again, device specific, and we'll type in VPN1, next hop IP. Get rid of all of this, and add, and then add one more time. Oh yeah, you have to give it a different name. That's right, I forgot about it. That's another variable you have to, it has to be unique. So what we're gonna do is, on VPN1 IPv4 prefix, we'll say VPN1, I'll put in here loopback prefix. Okay, that does that. And then I'll create a new IPv4 route. And this one will be LAN1. So you can make that a LAN1 prefix and go from there. And then we're going to say next hop, we'll put in here next hop IP LAN1. LAN1, there we go. It's got to be specific. Click on add and then mark as optional as well and then add. Okay, so now if I were to go in here and look at this, we've got VPN1 IPv4 prefix, and we also have this one here, which will be the loopback, or that's LAN. Let me just make sure that this one is unique. Loopback prefix, like so. Save changes. Okay, so if we were to go here and look at this, it's the VPN1 IPv4 loopback prefix with the next hop. The next hop is, there we go. And then this one here is going to be the VPN1 IPv4 LAN prefix. So it's going to be the subnet associated to it. So it's unique to what we're doing. So there we go. So I'm going to go ahead and I'm going to click on update. And now we have to go in here and populate the field. So this is going to be VEdge2. Notice we have the two variables. So we're going to come in here and edit device template. And so we have a couple of things. We have, these are optional. So if you have a site that doesn't need the config, you don't have to push it. So this here, the prefix that we're going to point to is going to be 10.1.0.16/32. And then we're going to say the LAN1 prefix is going to be 10.5.16.0/24. And then the next hop will be 10.2.16.16 and 10.2.16.16. We're going to use the same next hop IP to reach both. I'm going to go ahead and click on update and then click next, and then we're going to do a config diff to see what the update looks like. It'll be the exact same stanza that we saw for the CLI variation, but we're going to go under VPN1, and we should see that we're going to say, in order to reach the loopback address of switch 16, point to 10.2.16.16, and in order to reach the prefix of 10.5.16.0/24, same, point to the next hop IP. Go ahead and configure devices, and then I'm going to push that config. Alright, well the push was good, so if we were to pull up the CLI and look at vEdge2, let's go ahead and log in real quick, and show IP route for VPN1, we should have two static routes. We have those going to the next hop, so I should be able to ping 10.1.0.16, and unfortunately it defaults to VPN0, so VPN1. And there it goes, I can ping that. I should be able to ping 10.5.16.5 from VPN1 as well, and I can, which means that because vEdge2 can reach it, then so should the rest of the devices. Okay, so let's go ahead and back to templates, and let's do the same configuration for the other devices. So we did the dual site. Let's go ahead and knock out the single site. So I'm going to go to feature template, and I'm going to adjust this for each one. So let's do single site VPN1 template. Let's go ahead and edit that. Then under IPv4 route, I'm going to create an IPv4 route. It's going to be device specific, and I'm going to type in VPN1, and then I'm going to say IPv4 loopback prefix. There we go. And then next hop, add next hop, device specific, and it'll be VPN1. I hate that when you mouse off of the field that it goes away. Next hop, VPN next hop, VPN1 next hop IP. Let's say loopback next hop IP. Get rid of all this other extraneous information right there. There we go. And add. And then add one more time. Mark as optional. And add. We're going to create one more. This one will be VPN1 IPv4 prefix like so. This will be LAN1 prefix, lab1, not lab1, LAN1. And then add next hop. This will be the device specific as well, VPN1 next hop. We're going to say this will be LAN1 next hop IP address. Get all that squared away, and then add one more, or let's go ahead and edit this one, mark as optional. Save changes and then update. And then we'll have to do the necessary updates for this one as well. So we're going to go ahead and we'll say edit device configs. So here we have, in this case here, since we're going to these sites over here, let me go ahead and minimize this for the moment. So we're going to go to, this is going to 10.3. So we're going to want to be specific to that site. So this will be the loopback, will be 13.13.13.13/32 and to 10.3.130.0/24. And we have 10.3.13.13 and 10.3.13.13. Now you might be wondering, why are you adding the same next hop IP if they're the same? Why can't you just do that globally? You could, 100%. But what I'm trying to show you is that you might be pointing to different devices. So one might be going to core switch 1, one might be going to core switch 2, and you don't want to, you're going to need different next hop IPs. So that's what I'm just trying to show you, that it is possible to do that. So I'm going to go ahead and click on update, and then do the same thing for 14. So this one here is going to be, I'm sorry, in this case here it would be 15. So 15.15.15.15/32, and then 10.150.0/24 via 10.4.15.15 and 10.4.15.15, and click on update. Go ahead and click on next. Grab the output real quick to make sure everything is squared away, and then once, there we go, config diff, we're going to add in those 2 static routes. A lot of configuration for just a little bit of adding, and go ahead and click on configure devices, push it out to both, click on OK, and then I will pause until this is all squared away. So a question you might have, do you have to sit here and wait? No, you don't. You could have this opened up in multiple tabs. You could say open a new tab and you can go do your template configuration over here and then do a new push. But to be honest with you, when you start doing too many things at the same time, I lose track. I will very easily lose track of what I'm doing, and especially if I get distracted by something, I tend to like to focus on what it is that I'm doing and wait until I'm done with what I'm doing before I move on to the next task. Because can I multitask? I can. I can be on the phone with somebody talking about something and then be able to focus on something else if it's something pretty simple, like configuring an IP address if I have the information right in front of me. So I can do both at the same time and maintain a conversation or listen to somebody. But if I'm trying to focus on 2 things that are pretty critical, I can't really only focus on one. I'm human. I'm good at what I do, but I'm human. So to negate the possibility of making a mistake, I'd rather focus on one thing like I am right now than have multiple tabs open and try to go faster. Because I find the faster you go, the more errors you tend to make. So if you go slow but smooth, slow is smooth, smooth is fast. I forget who said that, but I've heard a lot of military folks refer to that, slow is smooth, smooth is fast. Because when you're able to get into a groove and things are going, step 1, 2, 3, 4, 5, 6, 7, you're doing them in the correct order, and you're not trying to do step 2, 3, and 4 at the same time, and then you end up forgetting what you did. That's when I find problems creep into play, and I'm trying to avoid those. Trying to show you how I do things. So with that being said, we should be good to go there. So let's go pull up our CLI and make sure that VEdge 3 has a couple of static routes in it for those prefixes. And there they go. I have 10.4.150, and I have 15.15, 15, 15 coming across. So everything's working the way that I need it to. Last but certainly not least, let's go ahead and do the templates for the MPLS only site. So go to feature, click in here, go to MPLS only, and for the VPN1 template, we're going to go ahead and edit this, add IPv4 route. Let's go ahead and bring this guy over so we can see what we're going to be adding. IPv4 route, new IPv4 route globally for the prefix, and we're going to say that this is, we'll say VPN1 underscore loopback, IPv4 prefix, mark as optional, then add next hop. I'm going to show you that you can add the next hop globally. So in this case here, I'll type in 10.5.14.14. Now that, I'm sorry, 14, like so. Now my next hop is global. I won't have to type that in again. I'm going to click on add. I'm going to add another IPv4 route. Did I not add? Oh, I didn't add it. Next hop is global, cancel, add. There we go. So add a new IPv4 route. There we go. The prefix is going to be device specific. This will be VPN1. Yeah, I can't stand when I mouse away. Messes me up every time. The prefix itself, this will be VPN1 LAN 1 IPv4 prefix. That's good to go. Next hop we'll say is going to be 10.5.14.14, then add, and then add, mark as optional, add again. So there we have it. So I'm going to go and click on update. Give that a couple seconds for it to do its push. And I'm going to go edit device template. You're going to see that the only thing I need to update here is the prefix. So it's going to be, in this case here, 14.14.14.14/32, and then 10.5.140.0/24. I don't need to specify the next hop IP because it's already been defined. I'm going to go ahead and click on update, click on next, and then do a config diff, and you'll see what I mean. So there are multiple ways of doing it. You just have to go in there and play with it. So let's go ahead and config diff VPN1. There you go. 10.5.140, 14.14, 14.14, both settings to the next hop IP, configure devices, and we're going to go ahead and I'll pause until this is done. Okay, so the push was good, so let's go take a look at VH5. So I'm going to go log in admin and do a show IP route. So I should have those routes in the routing table, 14, 14, 14, 14, and then 10.5, 14, or 140, excuse me. And you'll notice I have all those other prefixes in here as well, which is what I want. So now if I go to 14, for example, here, and I do a show IP route, right? I have a default route. Let's go ahead and minimize this guy. So let's go take a look at this. If I try to ping 15.15.15.15, sourcing from loopback 0, give it a couple of seconds, and then it works. It takes a couple seconds for it to propagate, but that was probably some stuff like ARP had to happen and some other stuff. So I'm not going to get into why the pings dropped a couple times. No big deal. It is what it is. So the fact of the matter is, if I hit the up arrow again, it pings all good. Now if I go back here and I hit the up arrow and I do a trace, but then I add in numeric, I get to where I've got to go all day long. Let's do the same thing to, let's change where I'm heading to 10.4.150.15. Oh, we have ourselves a loop. So let's let it finish out. It's almost there. So we have a loop. How did I get a loop? Okay, so I ended up hitting, I say 10.4.150.15 from source loopback 0. So it got me to 10.5, got me to VH5, then it dropped me on to VH4. Then it got me to loopback 5, and then when I tried to respond, 10.4.15, it got back to 10.4.15, pointed back to 10.4.15. So the problem is over here on VH4. So show IP route VPN1. Okay, so those are all squared away. Let's take a look at iOS 15. Show IP route. That's a little weird, because what it should do is if I do it, oh, you know why? Because I don't have a, okay, so the problem is I don't have the loopback created. So let's go ahead and create a loopback, interface loopback 0. Actually, I'm sorry. Let's not do loopback 0. Let's do interface loopback 150. IP address in here will be 10.4.150.15/24. Okay, so do show IP interface brief, and then do show IP route. Alright, so that problem should go away now when I go back to 14. Hit the up arrow again, and it gets to where it's got to go. So what was happening was, the reason why we're getting this loop, which started, that's why you have to be able to analyze this. So we're good, and then, I'm sorry, to here, and then we see it point back to VH4, and then pointed back to iOS 15, and then it got into a loop. So basically what was happening was, we look on 15, before I created the loopback 150, I didn't have that route in the routing table. So what was happening was, iOS 15 was receiving that prefix, or for the message for it. It's like, well, I don't know what to do with that, so I'm going to go ahead and send it back to you. You're my default route. So if I don't know what to do with something, I'm going to point it to you, and then, but you're configured on VH4 to point to me. So that's what was happening. So being able to identify a loop is important as well. So I'm glad I actually got to show you guys that. So there we go. That was a pretty easy one to figure out. Let's go ahead and take a look at 15, and let's do a ping to 10.1.0.16, sourcing from loopback 150. Give that a couple seconds to do its thing. There it goes. And if I try to do a trace route to it, and I should be able to get to that all day long. Now let's change this up a little bit. And instead of doing that with 10.5.16.5, and I get to there all day long. So that means I have reachability everywhere I need to have reachability to. And let's go to let's go to iOS 5. And we'll do a show IP route VRF SD-WAN. And I'm going to do a ping to ping VRF SD-WAN to 13.13.13.13. There we go. If we do a trace route, VRF SD-WAN to 13.13.13.13, sourcing from, or numerically, I get there all day long. I get to switch 16, then VEdge1, then I jump over to VEdge3, and then I drop off where I've got to go. So ladies and gentlemen, our connected or static routes are working as expected. So pretty straightforward stuff. In the next video, we're going to take a look at doing some basic OSPF. We're going to go through some of the capabilities that go into that and get through all those details. Until next time, guys, thanks so much for stopping by, and I'll catch you guys in the next video.